Hello all. Now we are with our next problem. To find the equilibrium index of an array such that lower index is equal to the sum of them at higher indexes. So what does that mean? So here if you see this array, so we have the set of elements given. So these fall up in the lower index and these fall up in the higher index. So if you see, if you sum this gives 1 minus 1 and this minus 1, so which will give the result. So this is our equilibrium index, that is 2, which is at the indices 3. So now we will have to find the equilibrium index for this. So we'll do the program and we can analyze that or trace that out after that's written. Now we'll just need the size of the elements and that array that we have got it. Now we'll just solve our base case, like if n is the element, n equals to 0 or equals to null, then written minus 1. This is there. So now we will have to find the sum of the array, and also we'll take another parameter called left sum. So what does this mean? Like for int I equals to 0, I is less than n, I plus plus, we'll say we will have to get the complete array elements and sum it. So that will be our sum first. So once we have the sum in our hand, then we will have to do the comparison such that at some point our sum and the left sum both reaches that minus 1 and minus 1 at that particular indices point. Sorry. If of left sum, if suppose it reaches that point, then we will return 1 left sum plus equals to array of I, then we will return, and if we then don't find anything, we'll return minus 1. So this was our base case that I wrote. So next I said we have declared two parameters, sum and the left sum. So what is it used for? I will say, so first we will have to get a sum. Sum will be the summation of the entire elements of the array. So once that we have, so here in this case this will lead to okay, minus 1 minus 2 plus 2. So that will be 0. Actually our sum will be here, it will give 0 for us as the output. So let's trace this down. Let's take index, sum and left sum. So okay, first all the elements will be 0, right? So index so we start with 0, and then sum and left sum both are 0. So it is initially 0 0 0. Okay, so on the first index, when the index is 0, so that point of time, we know that our sum is initially 0. So what will be the left sum? So left sum, if on the first iteration, let's see, left sum will be left sum plus is equal to array of I. So what we'll have to do, we will have to add it. So this will become 0 plus minus 7. So first time it will be minus 7 on the first index. So now let's traverse again. So when we come to 1, we will see that, so it is 1. So 0 minus 1 is, but here it is minus of, oh sorry, it is 7, right? It's minus 7. So this will become, sorry, okay, I didn't do this with this. So at the first index, this also will become minus of minus 7, which will be plus 7. This will be minus 7. Then we will, on the first iteration, we will see that we will see on this first element, that will be sum minus, so now our sum is 7 minus 1 it is, so it will be 6. And this we will compare this with this, so these are not equal, so that's when we will check for the left sum. So this is not equal, this will be minus 7 plus 1, so which will be minus 6, right? So next it will be the second iteration, at the third iteration basically, so it will be 5, that is the fifth one. So we will have to do 6 minus of 6 sum minus that, so 6 minus 5 is 1, right? So that is 1, and then here it is minus 6, again this is not equal, so that's what we are looking at, right? If it is equal to then we'll written, else what we'll have to do, we will have to do left sum, we'll have to add with the, this is the minus 6 plus 5, so that will be what, minus 1. Okay, so this we did not, this was the on the second iteration. So now on the third iteration, what will be the thing? So it is 1 minus 2 is minus 1. So if we see, these two looks fine, looks same. So after this we will come to a point to check if left sum equals to sum. Yes, these two are same, then we will written 1, saying that we did find at the index 3. So that is our equilibrium. This will be our equilibrium index that we were looking for. So I am solving it with this, in this way. Thank you.